All right, you guys. Question number 7, I think, is where we left off. And it gives you 3 pieces of information for Americans and 3 pieces of information for the Japanese. And what it says is that the mean lifespan for Americans is 78.74, a standard deviation of 15 years. And it wants to know what that would look like compared to everyone else in America for a 90-year-old American. And then it gives us kind of the same information for the Japanese. It says that their average lifespan is 83.84. They have a standard deviation of 18 years, so a little bit wider spread. And it wants to know that if you have a 95-year-old Japanese person, how they compare to their respective populations. Like, so would a 90-year-old American compare better or worse to their own countrymen than a Japanese person at 95? So all it's looking for is the Z-score. We talk about the Z-score with your SAT score, and that's why you have to have a Z-score every year. So in case the test is harder, it's only looking at how you compare against everyone else, not how you compare against people who took a harder test. So maybe you look good, or if people took an easier test, then maybe you look worse for that. So that's why you guys really don't have anything to worry about. Well, I guess you guys are done with your SAT, so it doesn't matter. Never mind. It's just the Z-score. So the formula to find the Z-score is just you take your score or your whatever. So in this case, 90 is the age of the person we're looking at in America, minus the mean score. So we already know it's going to be a positive number. They have lived longer than the mean. Okay. Divide it by the standard deviation and you get positive 0.75. So if you were looking at your normal curve, remember the mean is at 0. One standard deviation is positive 1. So they're not quite one standard deviation over, but they're up here. They're pretty close, right? So they're about here. And then we look over at the Japanese and we find the same Z-score. In this case, their age or their score is 95 minus the average or the mean divided by the standard deviation. And they only end up at 0.62. So even though they lived in 95, they don't compare as well as this 90-year-old American does. Okay. All right, the following table contains the probability distribution of the random variable, the number of people in line at a registration window. So the first question is asking for the probability of 3 people being in line. And of course, we know that the probability table needs to add up to be 100% or just one whole. So I just did the math to figure out what number I would need to add to the rest of these to get 1, and that was approximately 47.9%. So it looks like at this particular window, there's always going to be a line, or more than likely there's going to be a line. Question B, what is the probability that at least one person will be waiting? So I add up the probability of one person is waiting plus the probability that 2 people are waiting plus the probability that 3 people are waiting. And you get approximately 52.1%. So it's more likely than not that there is going to be somebody waiting. What is the probability that 0 or 2 people? So I just add probability of 0 plus the probability of 2 to get approximately 26.2%. Compute the mean of this distribution formula using, and here is our expected value formula that we have been using. So you can follow it along, or you could put those 2 columns into your calculator and do it just like we did it before. Studies show that, and that was it for question 8. Question 9, studies show that about 10% of the population is left-handed. So if you randomly selected one person, what is the probability that they are left-handed? Well, they already gave us that, it's 10%, right? What page are we on? If you randomly selected 2 people, what is the probability that they are both left-handed? Well, then you just need to multiply those 2 probabilities together. So you just get it would only be 1% that both people are left-handed. If you randomly select one person, what is the probability that they are right-handed? Well, if the probability that you're left-handed is 0.1, the probability that you're right-handed is going to be 0.9. We're not going to worry about any ambidextrous people. And D, if you randomly selected 2 people, what is the probability that they are both right-handed? And that's just going to be 0.9 times 0.9, which is going to be approximately 81%. Question 10, identify the statistic parameter and sample population. So the way I always remember it, you guys, is the statistic goes with the sample. They're both S. And the parameter goes with the population. They're both P's. That's just the little way that I remember. In Baltimore County, I bet I meant to be county. In Baltimore County, Maryland, the average amount spent per week on gasoline consumption in a sample of 500. So we already know 500 is the sample. Commuters was 75. So and I made this yellow, I should make it blue because I made the sample blue above. Okay, so 500 is going to be the sample and 75 is going to be the statistic because 75 goes with 500. If 500 commuters was the sample, okay, all Baltimore County commuters is the population, and that means that the parameter is 72 to 77. Okay, and I think that answers everything that I wrote down below for A. In B, a sample of 100, I'm going to use blue for sample of 100 residents of Broward County, Florida, yielded 27 residents. So that's going to be the statistic. 27 residents work for the government. Thus 27% of these workers, or 100 residents, work for the government. So 27% would be the parameter. Are the 100 residents here a sample? Yes. Or a population? Are the 27% value a statistic or a parameter? And it is I circled statistic, but it looks like it is a parameter. This is why we watch the videos too. Good. Parameter, because 27, the percent is what's going with the population, and the just 27 was what was with the sample. In a survey of 1,000 citizens in Seattle, so we know the sample is 1,000 citizens, 570, so 570 would be the statistic. 57% is the parameter, and the population are all, and I'm doing the parameter and population again in blue. I shouldn't do that. All citizens is the population. And 57% is going to be the parameter that matches up. Yep. And while I'm here, I'm just going to, because it's going to drive me nuts, blue. What's next? We're almost done. A friend offers you the following deal. For a $10 fee, you can pick an envelope from a box containing 100 identical envelopes. However, each envelope has a different prize inside. 10 of the envelopes contain a check for $6. So 10 out of 100 is 10%. So this 10 that contain a check for $6, I have here, and this is the same expected value. So let me take a moment here and let you know. The expected value of X is the same as the mean of X, okay? These two things are the same. So I don't want you to get confused because sometimes I just say, oh, the expected value, or sometimes I say the mean or mu. They are the same thing. So that's why we're using the same formula, okay? So 10 envelopes contain a check for $6. That would be 10 out of 100 envelopes is where I get the 0.1, and 6 is for the $6. And here, 80 contain a check for 8. Well, 80 out of 100 is 0.8, and they each have $8 plus 6 contain a check for $12. So 6 out of 100 is 0.06, and they contain $12. Then what color? Pink. 4 contain a check for $40. So 4 out of 100 is going to be 0.04, and then 40 is the $40. And that's it. And that should equal 100. And then if you do that formula, your expected value could be 9.32. Now, that is how much you would gain from playing the game. However, you actually would have lost a few cents in the long run because you had to pay $10 to play the game. So you've actually lost money, but your expected gain from just playing the game was $9.32. Okay. Question 12. According to the CDC, 9.3% of Colorado residents have asthma. 7.5% of Florida. How many questions do we have? I just want to check this really quick. Oh, this is it. That's what I thought. Blah, blah, blah. 7.5% of Florida residents have asthma, and 11.2% of Maine residents have asthma. If you randomly select one person from each state, what is the probability that they all have asthma? So that would be, if you look down here at my tree chart, it would be Y and Y and Y, and you just multiply their probabilities together and you get approximately 0.078% that they all have asthma. Question B, what is the probability that a randomly selected person from each state does not have asthma? So in Colorado, if 9.3% do, then 90.7% do not. In Florida, same, we're just subtracting it from 100 to get that. So now question C says, if you randomly select one person from each state, what is the probability that you get all three without asthma? We do the same thing that we did for A, except we use our new numbers, okay? And so that's gonna be approximately 74.5% that you get somebody that doesn't have asthma. But if you look at the bottom, and this is kind of in the way, I wonder if I can move it a little bit. Okay. If you look at the no, 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 that's going to be that answer there. And then this last question, I wish I could move this somewhere else. If you randomly select one person from each state, what is the probability that you get at least one person with asthma? Okay. And what I had to draw this out to see, but everything I highlighted in red and yellow, everything I highlighted in yellow has at least one person that has asthma. And only the no, no, no is where nobody has asthma. So if you randomly select, there's a probability that at least one person does. You can either add all of those yellow numbers up, or you could take what we got from C and subtract it from 1, and you get approximately 25.5%. All right, you guys, I am available for any more questions, and maybe we could have a study session before you take your test on Monday. I'm going to send out a form and have you guys sign up, and we'll do a couple of, maybe even 3 different times for tests on Monday, because a lot of people have gotten in touch with me that their schedules are really weird right now. They're either working or doing some weird other scheduling things. So we may have to just take it at different times, and that's fine. Things are weird and things are just going to be weird. But maybe we can still do some study sessions and record it for other people. All right.